When we start rigging, the first thing we need to do is to create some groups in the scene to form a rigging hierarchy. This will make it look clearer in the outliner and also make it easier for us to find the corresponding nodes and functions later. The idea is actually the same as in our computer's operating system when we create folders. We create many folders, we name them, and when we need to find a specific file later, by looking at these folder names, their categories, we can easily find the file we want. So let's do this together. With nothing selected in the scene, press Ctrl+G to create a group. Let's call this group master. Then the same operation, with nothing selected, we press Ctrl+G again. This way we've created a group. Let's call it geometry. Then keep repeating the same operation. We'll call this one controls. And create one more group. Let's call this group rig nodes. Then we take these last three groups we created, geometry, controls, and rig nodes, and put them all under the master group as its children. Then take the actual models group and put it under the geometry group as its child. This way, look, a rigging hierarchy structure is complete. Let's look at the function of each group one by one. As we mentioned, these groups are just like the documents in an operating system. It doesn't have any rigging function itself. It's more for organization and categorization. Let's look at the master group. The master group is the top level group for all the rig's controllers and nodes. When we collapse this tree structure, the master group represents this entire rig. We can imagine if there are 5 or 10 rigs in the scene. When we collapse the tree structure for each one, the outliner will ultimately just show 5 or 10 master groups. This looks very clean. Then, when we expand the master group, we will see the corresponding categories inside. There are models, there are controllers, and there are rig nodes. When we need to find the corresponding node, we can go into the corresponding group to look for it. This will be more convenient. So next, we are going to create the first controller. This is a controller that every rig will have. It's called the world controller. This controller itself isn't used very often when animating. It's more for establishing the rig's initial position, initial size, and initial coordinate system orientation. We'll explain this in detail after we create this controller. Let's create this controller together first. We've talked about how to create controllers before. Let's do it together again. We click Create, NURBS, Primitives, and find Circle. Or we can find the circle in the curves shelf in the toolbar and click it. We've created a circle. Let's scale it up, scale it larger than the entire model. But we must note here, this controller itself must be at the word origin. I think this is about right. Then freeze transformations, then delete history, Alt plus Shift plus D. Make sure we don't have any node connections down here. Then let's rename it. We'll rename it here, call it control C word 0001. Speaking of naming, I need to add a quick note. Whether we're naming controllers or naming these groups and nodes, we want these names to be as generic as possible. Some of us might fall into a trap. When creating a controller, or for example creating these master geometry groups, one might think, okay, this group is called master now. When I create a new rig, that rig might not be a car. It might be a person. If that top level group is also called master, won't the two names conflict? So when naming to differentiate them, I'll add, for example, Jeep here. And for that character's master, I'll add, for example, human or the character's name. This thought process itself is very good, but in practice, this isn't how we do it. First of all, when we reference each rig in the animation scene, we actually have other methods to differentiate the nodes within each rig. What is this thing? This is actually in the check model section, what I mentioned to everyone, namespace. Let's take a quick look here. For example, I create a group. Let's call this group Group 1. Then I'll create another group here. Let's just call it Group 2 for now. Then select Group 1. Go to Windows, find General Editors, and inside is the namespace editor. Then let's create a new namespace. For example, let's call it Rig 001 to represent our first rig. Select Group 1 and then select Rig 001, which is the namespace we just created. Then here select Add Selected. This way we will see Rig 001 colon will be added in front of Group 1. Then let's create another one. We select Root. select New here. And similarly create a rig 002. Then select Group 2. Here, also select Add Selected. Then let's change this 2 back to 1. Now this way look. Although the names of these two nodes are the same, because of the namespace, their prefixes are different. So Maya will consider them two completely different nodes. And it's also very easy when we want to search for them. For example, I want all the Group 1 nodes here. Although I don't know what the namespace is, I know there definitely is a namespace. So I use an asterisk here, followed by a colon. We know the colon is the symbol that connects the namespace and the actual node. And then we know the part after is Group 1. So here I type Group 1, press Enter. This will select both of these nodes. In fact, when we put all the rigs into the animation scene, Maya will automatically do this for us. It will add a namespace to every imported rig to distinguish the nodes between different rigs. So we don't need to worry about node names repeating between rigs, because they belong to different files. And when we import them, they will be differentiated using namespaces. So let's delete everything we just created. Close this and delete the two groups we just created. Another reason we try to keep each node's name as generic as possible is that because in the future, we will need to write some script functions for many rigs to control them all uniformly. We will want this function to be compatible with the vast majority of rigs. For example, if I write a very simple function here, select the world controller, move the world controller forward 1 unit in the z-axis. A very simple function. When we write it, we will search for the world controller in this rig. This world controller, its name is Control-C World 0001. Now if I have another rig, and because I wanted to differentiate from others, I called it, for example, Control-C World Tom 0001. Well, the tool I just wrote will no longer apply. I would need to keep adjusting this script. This is clearly unnecessary, so we need to be careful here. When we are naming these controllers and nodes, try to make them as generic as possible with other rigs. If it's the same function, especially something like the world controller, which will absolutely appear in every single rig, we must make its naming as generic as possible. So we've created this controller. Next, don't forget to group it. We'll call this group 0. Then we put it under the controls group as its child. Then we need to set a color for it. So we select the controller, press Ctrl+A to go to the attribute editor. Find the shape node for the NURBS curve. Then in object display, find drawing overrides. Then check enable overrides. And then we pick a color. I'll use purple here, the second one from the end. We'll use this purple to represent the world controller. Alright, next we need to use the controller to control the model. I'm sure we are all very familiar with this step. We create a group, and this group, we'll call it Trans-C Low World 0001. Then we do a parent constraint with the controller. Turn off maintain offset. Then let's do a scale constraint, because we will need to control changes in the model size via the world controller. Although we mentioned earlier that the size of each model is determined in the modeling step, but we also mentioned we might fine-tune the model size based on the shot. And this fine-tuning is done through the world controller scale. So we have this group now. Let's put this group under the geometry group and put the model under this trans group. Now let's check again. When we move the controller, the car will move along with it. Now we can explain in detail what the world controller's main job is. By default, models are at the world origin, but in an animation scene, it's very likely it won't start from the world origin. It might start from, say, this position, start from this position, start from this position. At this point, we need to move the world controller to this position. This car will have other controllers later. When we use other controllers to animate, it will start from this position, because they will all be children of the world controller. So when we zero out these controllers, their position will be at this current position, treating this position as the initial position. Same idea if we need to scale this model for the shot. We scale it up a bit. This is also done through this controller. Another very important point, we briefly mentioned it earlier, is that it defines the initial coordinate system orientation. What does that mean? Look, the default is z-axis forward, which is consistent with the world coordinate system. But it's also possible that this car in this scene is always driving to the right, always moving in this direction. So what do we do? At this point, look, when I rotate the world controller nearly 90 degrees around the y-axis, we can imagine the rest of the controllers, since they are all its children. When we move them forward and backward, their orientation will change. For example, if I move the models group now, and I switch this move tool back to object mode. Now look, when I move it on the z-axis, its current orientation is actually moving towards the front of my screen, which is the world's negative x-axis direction. If I zero out the world controller's rotation and then move the model's z-axis, it moves in the world's positive z-axis direction. These are all achieved by changing the world controller. Let's zero out the world controller. Next, let's do some simple cleanup. First, for the controller itself, we do not want our car to have single-axis scaling, because the car's proportions are already set. If we want to change its size, we would only change its overall size. Because this is a realistic rig, we don't have any cartoony effects to implement here. So what do we do? To ensure we don't have a situation like I just demonstrated, where the whole car scales on a single axis, we add an attribute here. Let's call this attribute rig scale. The minimum value is 0 and the default value is 1. We know the default value for scale is 1, right? So our default value should also be 1. But we can set it to 0.5, 0.2, 0.1 to make it very small. But likewise, we can make it 2, 3, 4, 5 to make it bigger. Let's add it, then go into the connection editor. Select the controller itself on both sides. Then only show keyable attributes. This way, we have the rig scale overall scale attribute, and we'll connect all 3 scale attributes. This way, when we change the rig scale attribute, it will definitely control all 3 scale attributes at the same time, rather than just one of them. So we know these 3 scale attributes, we don't want the animator to touch them. So select these 3 attributes, right-click and lock and hide selected. Similarly, let's lock and hide the visibility attribute as well, because we also don't want animators to hide a specific controller. This way, the controller cleanup is done. Next, let's do some cleanup on the master group. First, the master group's own translate, rotate, and scale are not needed, because as we said before, the master group just represents the rig's highest level node. It's just to make the outliner look tidier and cleaner. So here we lock and hide its translate, rotate, and scale. But we will need the visibility attribute, because this way we can hide all nodes of the entire rig. Very convenient. Then next, we need to toggle the visibility for each category underneath. These can all be controlled from the master group without having to switch to each corresponding group to change its visibility attribute. We go to Edit, find Add Attribute. Here, first, a setting to hide or show the model's group. Let's call it Geometry Vis, which is the first 3 letters of visibility. We don't need this to be keyable, it's just a setting for the display state. So we select displayable here, and it's a boolean because it's only on or off, 0 or 1. So add that. Then we also need to add a model display type, because for the animator, we don't want the animator to actually select the model itself. They should only be able to select controllers. If they set keyframes on the model itself, that's clearly not what we want to see. So generally speaking, we will set the model's display mode to reference. This way it can be seen but not selected. When we connect this later, we'll explain this in detail. So here we select enum. Also select displayable. The first option is normal. The second is template. Then select the blank space. We enter the third one, reference. We add it. Next is controls. Controls is also a show or hide, so this is also displayable and boolean. And next is the rig nodes. This is rig nodes with. And the same settings, displayable and boolean. Okay, now that we have these attributes, we need to connect them to the corresponding groups. Again, find the connection editor, then find geometry. Now look, under my master group, the attributes I just created don't exist. Why is that? It's because non-keyable attributes are not shown here. Those ones we just made are not keyable. So let's find it. Geometry Vis. Connect this to its visibility. Okay, see, our model is gone. Then geometry display type. We can't find this attribute in the geometry group. That's because it's also a non-keyable attribute. So let's show them. Where is this attribute? This one is hidden pretty deep. Look at this drawing overrides. Expand it, and there are many attributes here. We find the first one, override display type. Select this. Next is controls. Select this attribute for controls. Because we are just connecting visibility, we know it's keyable. Let's turn this off. And here we find the control width we just created. Connect it. Finally, rig nodes. Same operation. Then let's turn all of this back on. And let's go into geometry here. Then in display, find drawing overrides. And let's turn on our enable overrides. Because if we don't turn it on, the display type underneath will have no effect. Now look, it's set to normal. Normal is the display mode we usually interact with models in. We can select it, it's visible. Now if we change this to template, then look, it will turn into a gray wireframe display, and we cannot select it. If we try to render, we'll also find that we can't render this model at this time. And then there's reference. In the reference state, the model is renderable, but we cannot select it. This type is the setting we will ultimately give to the animators. Because we don't want animators to actually select the model, we want them to use the controller's movement to make animation adjustments to the rig. But since we are still in the rigging process, we need to select the corresponding models to put them in the right groups. So to make it easier for ourselves, we set it to normal here. This way, we can select it and set up parent relationships for them. Now let's look at these three groups. The translate, rotate, and scale for these three groups are also useless. So we select all their translate, rotate, scale, and visibility attributes. Right-click and lock and hide. Then collapse this tree structure. This way, our first wall controller and the rig's hierarchy structure are all done.